Am I audible clearly to all of you?
Yes, sir.
Yes, sir.
Okay, so today we are going to start this chapter and complete this chapter as well. This GOC. GOC is backbone of organic chemistry. So you have to be careful while solving this question. Every questions of organic chemistry can be related to this GOC. At the end of every question, we have to deal with this GOC, that is general organic chemistry. So this general organic chemistry, we are going to cover the topic inductive effect and its application, then mesomeric or resonance effect, then method to decide whether which one is more stable and which one is less stable, then the most important aromatic, anti-aromatic and non-aromatic compounds, then hyperconjugation, then we will talk about bond length and bond energy. As you know that bond length is inversely proportional to bond energy. If in a compound bond length is larger, that means it is easily breakable, that means its bond energy is lower. You have studied about this basic things. And then comes to the stability of carbocation, that means carbon has positive charge, then carbon anion, that means carbon has negative charge, that is carbon anion, and carbon free radical, that means carbon has a free electron or unpaired electron. Then we will talk about acids and bases. Okay, now moving to the first topic, that is inductive effect. Before that, I'm gonna show you this. This is basically electronic displacement effect. What is electronic displacement effect? Basically, the effect in which electron displaces, that is called electronic displacement effect. And this is of two types. This is of two types. One is permanent effect and another is temporary effect. So we don't need to deal with the temporary effect. These are of two types. You need to take care of this only. Inductomeric effect and electromeric effect. What we need to study is this inductive effect. Inductive effect is a permanent effect, then mesomeric or resonance effect, and then your hyperconjugation. These three effects are permanent effect as well as very important in our syllabus. Then moving to the first effect, that is inductive effect. What is inductive effect? Basically, if you want to define basically what is inductive effect, inductive effect is due to the electronegativity difference. Whenever there will be electronegativity difference not equals to zero, where their inductive effect will take place and inductive effect will be there. As for example, you know that this is your CH3Cl. That means carbon is connected to chlorine directly, and you know that chlorine is more electronegative than this carbon. So what will happen? Chlorine will have delta negative and carbon will have delta positive. There is polarity in this bond, and hence this is inductive effect. This is called inductive effect. Inductive effect here is not equals to zero. So in a compound, wherever the electronegativity difference is not equals to zero, there will be something difference in their electronegativity, that is called inductive effect, and it operates through only sigma bond. It operates through only sigma bond. Is that clear?
Yes.
Please do respond. Alan, Hiba, Aksa, Farhad, Hanifa,
So
Yes, sir.
and I think Muhammad sir. Okay. So see, it's the inductive effect is very easy. As you know that due to this electronegativity difference, an element cannot gain the electron here. Only there is a partial displacement of electron towards the more electronegative element. That is called inductive effect. Okay. So also it's very important to note that this inductive effect is inversely proportional to distance. This inductive effect is inversely proportional to distance. As you can see, if you are standing here and you are gonna pull your friend from here, and your friend is gonna pull another friend, and then so on. You can see the most force that the most, or you can say the greater force that your friend will feel, that a friend will feel the greater force of attraction towards you. What I want to say is that chlorine will withdraw electron from this carbon, this carbon, this carbon, but the force of attraction towards chlorine will be more at the first carbon, then second carbon, and then third carbon. That means inductive effect decreases with distance. That's why inductive effect is inversely proportional to distance. And always remember that after third carbon, inductive effect almost equals to zero. Are you getting my point? Chlorine can easily attract electron from here and here too, but the force with which chlorine is attracting electron from this carbon, here it will be lesser, and then here it will be very, very less, and at the fourth carbon it is almost zero. Okay, now moving to the next, that whatever I just explained, I have written here, and this notes will be sent to you in PDF form, the same notes. Causes of inductive effect is due to electronegativity difference. It is a permanent effect, and it is a weak effect because of partial transfer of sigma electron. First of all, you need to take care of this. Inductive effect operates through sigma bond, and sigma electron partially displaced, not completely displaced. If completely displacement will take place, the effect will not be known as inductive effect. And here I have again written here that inductive effect inversely proportional to distance. Then after third carbon, inductive effect is considered as negligible. And also it's very important to note that the inductive effect of hydrogen we consider as zero. Is that clear to everyone?
Yes, sir.
Okay. So whenever there will be a question in which of the following inductive effect is occurring or inductive effect is taking place, so what you need to calculate or what you need to see is only the compound in which electronegativity difference is not equals to zero. In that compound, electronegativity will take place. Sorry, inductive effect will take place. As for example, I'm gonna give you a very good example. If I'm gonna ask you this, is there any inductive effect in this? You can see this is your carbon, this is also your carbon, this is also your carbon, and this is also your carbon. These all have same electronegativity. That's why inductive effect, electronegativity difference, if you are going to check it, equal to zero. That's why inductive effect here will be zero. There is no inductive effect in this. Everyone getting my point?
Yes, sir.
But if you are gonna take this fluorine, I'm gonna put a fluorine here. You can see carbon is here, carbon is here, carbon is here, carbon is here. Between carbon electronegativity are same because all are carbon, but here you can see fluorine is more electronegative than carbon, so there will be delta negative and there will be delta positive, and here inductive effect will take place. Inductive effect is occurring. Is that clear? There is another way to look at the inductive effect. If same carbon or carbons are present, you can see I'm going to do this. Can anyone tell me whether inductive effect is taking place here or not? Can anyone tell me?
Yes, sir, it is.
Yes, taking place or not, Alan?
It is. Yes, sir.
Yes. Can you give me a reason why it is so?
So because they're in double bond that's sigma and pi bond. So
very good, very good. See what will happen. Carbon is here, carbon is here, carbon is here, carbon is here. This all are carbon, but you don't think like that. Since all are carbon, they will have same electronegativity and inductive effect not taking place. You can see this is your sp3, this is your sp3, and this is your sp2, this is your sp2. So between sp2 carbon and sp3 carbon, as you have studied in class 12, carbon having sp3 hybridization, carbon having sp2 hybridization, carbon having sp3 sp hybridization. This is the order of electronegativity of same element, that is carbon, depending upon the hybridization. As you know, S character increases and electronegativity increases. So in sp we have 50% S character, in sp2 we have 33% S character, and in sp3 we have 25% S character. Due to this S character in sp carbon, it is more electronegative, and here we have an option sp2 and sp3. That's why there is a delta negative here and there will be delta positive, and inductive effect taking place here. Is that clear? Students can easily get when different types of element combine with this carbon chain, but when it will come about the carbon, like the hybridization, you have to be careful. Everyone knows that sp2 sp3, yes or no? Can I change the
Yes, sir.
slide? Okay. And also please do respond, Hiba.
Yes, sir.
So, okay, Hanifa. Okay. Now see, we have inductive effect that is of two types. That is of two types. As you have seen that when I had written here like this, so I had written here delta negative on fluorine and delta positive on carbon. So you know the nature of chemistry. Nature of chemistry. If some substance which has, or some elements which has positive charge, that means that substance or element donated electron. And if some substance or elements will have negative charge, that means that gained electron. So just like that, F negative, that means this is basically took electron. So it will have a characteristic of inductive effect, that is minus I. So, and this since donated, that's why it is plus I. What I want to tell you is that you can see inductive effect is of two types, plus I and minus I. The one which donate electron, or the one which has delta positive charge, the one which will have delta positive charge, that is plus I, and the one which withdraw electron towards itself, and the one which will have delta negative charge, that is minus I. Is that clear? Please do respond.
Yes, sir.
Now the next point, which is very important, this alkyl group, you are aware of this alkyl group. Alkyl group is what? Alkyl group is basically methyl, ethyl, propyl, butyl. This all alkyl group has a tendency to donate electron. That's why they act as plus I group, plus they act as plus I. That means donating group. These all are donating group via sigma bond. Why I wrote here sigma bond? Because inductive effect proceed through sigma bond, not pi bond, not delta bond. It only proceeds through sigma bond. And always remember, methyl, ethyl, propyl, they has a tendency to give electron, donate electron. That's why R is plus I. Can I change the slide?
Yes.
Okay. Okay, so here is your question. Okay, wait a minute. Just let me find the encircled group. I'm gonna encircle it. You need to tell me whether fluorine is acting as plus I or minus I. CH2 is acting as plus I or minus I. CHO is acting as plus I or minus I, plus I or minus I, plus I or minus I, and plus I or minus I. You need to tell me. So what you need to do, just write in chat box one I, minus I, or plus I. If you're going to identify this, I'm going to give you, how many question is there? 7 question is there. I'm going to give you 2.5 minutes. 5:27, I will be checking it. Just let me know. And you can do it within a minute. It's very easy. If anyone wants to tell me on mic, just tell me.
Sir, can you scroll up?
Scroll up, that means like this.
Yes, sir.
Okay. Are you writing it, Sir?
No, I just want to see the definition for minus I effect.
Okay, minus I, you know that if some elements have negative charge, that means it took electron, gained electron, withdraw electron. Okay, and plus I, that means donated. Can I change the slide now?
Yes, sir.
Okay, someone has texted me. Who is this? H. Hiba? No. Hanifa? Okay. Oh, Hanifa, is this you? Okay. AJ Allen, very good. Very good. MS. Who is MS? Okay. Mohammed Saifullah. 2 plus I. No, not plus I. I think Hanifa, you are wrong. Hanifa green, Hiba blue. Okay. Mamuna, waiting for your answer. Farhat, Aksa. MS. No, not plus I. Two. Are you talking about this, right? Second two. How can it be plus I? See, I'm gonna fluorine is just you need to see to which group it is attached. This is your carbon, and fluorine is more electronegative, so it is minus I. Now you can see this is also your carbon, this is also your carbon, but this carbon is your sp2 and this carbon is your sp3. This carbon is your sp2 and this carbon is your sp3. That's why it will be acting as minus I. sp2 carbon is more electronegative than sp3. Okay, then moving to this, you can see this is also carbon, this is also sp2. You can see this, very good. This is sp2 and this is also sp2, but what is the difference? To this sp2 carbon, a very most electronegative element is connected, oxygen. That's why this oxygen will be withdrawing electron from this carbon and there will be deficiency of electron on this carbon. That's why this carbon will be taking electron from this carbon and hence it will be acting as minus I. Please be careful about this because you can see both are carbon, both are sp2 hybridized, but with this CHO carbon, oxygen is connected and oxygen will continuously take electron from or withdraw electron from this carbon and hence there will be deficiency of electron to this carbon. So it will be hunger for the electron, so it will take from here. That's why it is minus I. Oxygen more electronegative than carbon, minus I. You can see this is carbon, this is also carbon. It is sp3, but this is your sp2. So this is more electronegative, so it will donate. So this will be plus I. Then moving to this part, this is your carbon. This is your carbon, which is sp, and this is your carbon, which is sp2. sp carbon is more electronegative, so this triply bonded will be minus I. You can see this is your carbon with sp2, and this is also your carbon with sp2. So there is no inductive effect. Inductive effect is zero here. Is this Farhat minus I, second one plus I. The second one is wrong, and third one is minus I. Very good. And the fourth one is plus I, not plus I, because oxygen is more electronegative. It will take electron. Fifth is plus I. That's good. And sixth is what? Sixth is minus I. Very good. And seventh one is not plus I. You can see this is the scenario. Every atom is carbon and every carbon is sp2 hybridized. So you can understand easily that by the definition of electronegativity of carbon, it will not be possible. And also, if you are going through hybridization, it is also not possible. So it will be inductive effect, there will be zero. Is that clear to everyone? Is that clear to everyone?
Yes,
Yes,
sir.
sir.
Can I change the slide? Alan, Hanifa, Saif, can I change the slide?
So
Yes, sir.
Okay, thank you. Moving to the next part, which is very, very important, and I will recommend you to please do write it. This is the series of minus I and plus I as well. First, let me explain it and then you are going to write it. So the most withdrawing group or the most withdrawing power of the group, that is NF3 positive, then NF3 plus NH3 positive NO2 CN. NO2 is more having more electron withdrawing power than CN. Then fluorine, chlorine, bromine, iodine. Then this is your triple bond. Always remember that. Always remember that this is your triple bond alkyne and this is your NH2. You have to be careful. The electronegativity of carbon, which is sp hybridized, is greater than the electronegativity of nitrogen, which is sp3 hybridized. In this case, amine, in amine, you can see. And then comes your phenyl, and then comes your alkene, and then hydrogen. In the same way, you can go for plus I series. So please make a short notes of this plus I and minus I. This will be very helpful while solving the question of stability as well as acidic and basic character. Please do write it. Everyone done with this? Saif?
Yes, sir.
Okay. Please continue up to this. This is the plus I effect for T. T is for tritium, which is isotopes of hydrogen. D is for deuterium. Then comes your H for hydrogen or protium. This is the donating tendency of the isotopes of hydrogen. Let me know when you are done with this. Are you done with this? Okay. Now, the next topic is your application of inductive effect. Intermediate. What is intermediate? Basically, intermediate is that substance which is reactant, sorry, product for one reaction and reactant for another reaction. What I want to tell you is that intermediate is that substance which is product for one reaction and reactant for another reaction. Is that clear? This intermediate is in between the main reactant and the main product. Now moving to the next, which is very important. We can get intermediate of carbocation, that means C positive, carbon free radical, that means C dot, free electron, unpaired electron, carbon anion, that means C negative. And to get this carbocation, carbon free radical, and carbon anion, we need to do, for carbocation, we need to do heterolytic cleavage or heterolytic fission. Heterolytic fission. More electronegative element will give charge on carbon. And hence, you can see carbon is now making only 3 bonds. That's why it will have 6 electrons. And its octet will be incomplete. And 3 sigma bond, that's why it's free, trigonal planar. Again, if you need to do the carbon free radical, if you want to get carbon free radical, you need to do the homolytic cleavage. That means each one will take its own electron. You know that 2 electrons are required in a bond, or 2 electrons present in a bond. So what will happen here? Each one will take its own electron in this way, and carbon free radical will form. A carbon free radical will form. Now, this is called homolytic cleavage, when each one will take its own electron. Octet incomplete because 3 bond is making with 3 hydrogen and 1 electron is free. So 7 electron is there. And again, the hybridization will be sp2 and geometry will be trigonal planar. And for carbon anion, carbon will take electron from the another one, and the fission will be heterolytic. And you can see 8 electron complete sp3 trigonal pyramidal. The geometry will be. Is that clear, everyone? So you need to take care that which one is complete incomplete octet, which one have complete octet, and which one has incomplete octet. And for carbocation, you need to do heterolytic cleavage or heterolytic fission, and carbon anion, you need to do heterolytic cleavage and heterolytic fission. And for carbon free radical, you need to do homolytic. Can I change the slide? Aksa, you are not responding at all. Mamuna, you there?
Yes,
Or
sir.
okay. So just let me know. Can I change the slide?
Yes.
Okay. Now you need to do this question. You need to arrange this question. Which one is more stable? Which one is less stable? Compare the stability. For the first one, which one will be more stable? MS. MS. Very good, sir. Alan, no, not BACD. Okay, let me explain. See, this is your carbocation. That means it is having electron deficient. And you need to look around the groups that is attached around this C plus carbocation. So CH3 is there. CH3 is there. That means CH3, I told you, it is a methyl alkyl group which has plus I tendency. That means donating tendency. So this will be getting electron from 3 side. This will be getting electron from 2 side, and this will be getting electron from 1 side, and this will be getting from none side. Okay, so the one which will get more and more electron, because there is a deficiency of electron, that's why it is stable. Or you can say this is your 3-degree carbocation, 2-degree carbocation, 1-degree carbocation, and this is your super primary. So the stability order will be A, B, C, and then D. Is that clear, everyone?
Yes, sir.
Okay. Now moving to the next, let me see the answer that is very good, Seth. Now see, this is a carbocation. This is also a carbocation. That means having the deficiency of electron. That means having the deficiency of electron, it requires more electron. Now the group which is attached nearer to this is NO2. That is different. It will get electron from this side, this side, this side as well. But NO2 is there, which has a tendency to withdraw electron. So it will withdraw as well. This will also will withdraw, and this will also will withdraw. What I want to tell you is that this carbocation needs electron, but there is a group which is withdrawing these electrons. Already that carbocation has deficiency of electron, and this NO2 has a tendency to withdraw electron. That's why this will be the order, because this NO2 is nearer to carbocation and it can withdraw. It will withdraw more and more electron, which will increase the instability of this carbocation. That's why it is very less stable than NO2. This NO2 is farther from this. That's why then, and this is very far away from carbocation. That's why this will be the most stable, because this will not be able to withdraw electron. This carbocation already facing the problem of electron deficiency of electron. It does not have any it doesn't have enough electron, but NO2 has a tendency to withdraw electron. That's why this will be the order CBA. Then coming to the next, that is this one, the third one. You can see carbocation. Very good, Ajay. Very good, Alan. So this is carbocation. Now you need to think about this CH3, CH3, CD3, CD3. What will happen? Which one will have the more power to donate electron to this carbocation? Because this carbocation facing deficiency of electron. So as I told you, T has more tendency to give electron than D, than H. That's why the order will be C, B, A. You can see CD3 will be more stable, because this tritium will donate more electron than deuterium, and deuterium will donate more electron than hydrogen. That's why. Is that clear? There is a rule for the fourth question. There is a rule that is DNP, distance, number, power. We give preference to distance, then number, and then power. Now see, you can see this is carbocation. This is also carbocation. Okay, so this is also carbocation, and the group which is attached with this is fluorine, and the group which is attached with this is NO2. Which one has more power to withdraw electron? NO2, but NO2 is farther from this carbocation. That's why it will not be able to withdraw more electron, since both has a tendency to withdraw electron, which decreases the stability of carbocation, because carbocation has deficiency of electron. So NO2 will not be able to withdraw that much electron. So that's why this will be the stability order. Everyone getting this point, yes or no? Distance will dominate over number and power. So here we used distance number, sorry, power. Is that clear, everyone? Now moving to this carbocation, carbocation. Cl is there, NO2 is there at the same position. So you know that carbocation is facing problem for electron and chlorine is withdrawing electron. NO2 is also withdrawing electron. But there are two chlorine which will withdraw more and more electron than one NO2. So this will be the order. Is that clear, everyone? Please do respond.
Yes, sir.
Okay. So I'm gonna share. Wait a minute. I'm gonna share a page of. Wait a minute. So it is a question from NEET Odisha. Can you see the screen? A new screen. Can everyone see the new screen?
Yes, sir.
Okay. So this is what I want to ask you. Question number 41. Very good, Alan. Is there any other answer? B. Wait a minute. Wait a minute. B. Okay. 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 The answer is basically your D. See what happens here. First of all, this will not be because it is 1 degree. This is your 2 degree, and this is also your 2 degree, and this is also your 2 degree, right? Everyone knows that. I told
Yes,
you
sir.
the carbocation will have a 3 degree, 2 degree, and 1 degree. Now we are stuck that these all are 2 degree. These all are 2 degree. Now, if you are going to draw the structure of this CH plus, and here it will be CH3, and then C, and on a single carbon there is CH3, CH3, CH3. That means steric hindrance will be there and it will not be that much stable. That's why B will not be our answer. Is that clear?
Yes, sir.
Alan?
Yes, sir. Then why is it
Now
not C?
come to the C and D. If you are going to talk about C and D, CH plus both are 2 degree. But here, if you are going to see, there is bulky group that is CH3, CH2, which is also unstable. That's why our answer is D. That's why our answer is D. Now there is another way to explain it, which is quite easy. Are you aware of hyperconjugation? Yes or no? Please do let me know. Are you aware of hyperconjugation? Alan, Mamuna, Saif, please do respond yes or no. So that I will
Not much, sir. Not much.
Okay.
No.
See, see, I'm going to explain for a while. You can get it easily. With the help of hyperconjugation, this can be explained easily. You can see this is your carbocation. That's why this will be your alpha carbon. That means the carbon which is directly connected to carbocation, that is your alpha carbon. That is your alpha carbon. And this carbon has two hydrogen. That's why it is two alpha hydrogen. It is having two alpha hydrogen. Is that clear, everyone? Now, if you are going to see this is your alpha carbon and this is also your alpha carbon. But this alpha carbon has zero alpha hydrogen and this alpha carbon has three alpha hydrogen. Now, moving to the next. This is your alpha carbon. This is your alpha carbon. This has two alpha hydrogen. This has two alpha hydrogen. That means this has total four alpha hydrogen. Now, coming to the next. This is alpha carbon. This is alpha carbon. This has three hydrogen. This has two hydrogen. So it will have five alpha hydrogen. Always remember that number of alpha hydrogen directly proportional to stability. Number of alpha hydrogen directly proportional to stability. That's why our answer is D. Whenever we step in inductive effect, we will go through alpha hydrogen. Is that clear? Can I change the slide?
Yes, sir.
Okay. Now moving to the next on our syllabus. This. Let me know when you are able to see the screen. Are you able to see the OneNote?
So
Okay. Now the next topic is resonance. The next topic is resonance. What is resonance? See, our inductive effect operates through sigma bond. Partial displacement of sigma electron took place. But here in resonance, the first point is complete transfer of pi electron, not sigma electron. Pi electron. Complete transfer of pi electron takes place. That is also called delocalization of pi electron. Pi electron will move from one place to another place according to the situation. That depends upon the conjugation. We will talk about conjugation as well. And due to this delocalization of pi electron, there are resonating structure. A molecule can have different or more resonating structure. That resonating structures are hypothetical structure. That resonating structure are hypothetical structure, and then comes the resonance hybrid, which is real. This resonance hybrid will be drawn with the help of resonating structure. But resonating structures are hypothetical structure, but resonance hybrid is real structure. Is that clear? We will draw some resonating structure. You will see. Now, always remember that in resonance, only pi electron moves. Atom don't move. Only pi electron moves. Atom don't move. Okay. Always remember that in resonance, only pi electron moves. Atom don't move. If in a resonating structure, atoms is moving or atoms are moving, then that is not a resonating structure. And also remember that this is also very important. In resonance, total electron are conserved or the charge is also conserved. If in a resonating structure, if you have total charge neutral, then in another resonating structure, you will have total charge neutral if you are going to add them. And if in a resonating structure plus one charge, then in another resonating structure, there will be overall plus one charge. Is that clear? Is that clear, everyone?
yes, sir.
Alan, Mamuna. Saf, are you there? Okay, thank you. Now see, I was talking about the conjugation. How will we know whether we need to do the resonance or not? Resonating structures are possible or not? Resonance is taking place or not? So this is the conjugation. If you will see pi, if you will see pi, sigma, pi, this is the conjugation. If you will see pi, sigma, vacant orbital, positive, that means vacant orbital, this is conjugation. Pi, sigma, negative charge, it is also conjugation. Pi, sigma, lone pair, it is also conjugation. Pi, sigma, and free radical, it is also conjugation. Negative charge sigma vacant orbital, it is also conjugation. Lone pair sigma, and vacant orbital, it is also conjugation. We will take example of each and we will understand. Now there are some arrows that is used during resonance or during this chapter. This arrow shows heterolyte single. Like if I'm gonna show you CH3Cl, you can see chlorine is gonna get all the electron. It will have delta negative, and this will have CH3 positive. This is heterolytic fission. Homolytic fission, if you are gonna do the homolytic fission, that means it will take its own electron, half arrow, and it will be like homolytic fission. And with homolytic fission, we get free radical. And this is the arrow that we use in between two resonating structures. And this is very important. Flow of electron will always take place negative to lone pair to pi bond to positive. If you have negative to positive, then negative to positive it will go. Negative and positive, negative to positive will go. If you have negative charge and lone pair, then negative to lone pair will go. So this is high potential to low potential. This is what? Negative charge, the high potential. Then comes your lone pair, then comes your pi bond, and then comes your positive charge, which is very low. Now, case one, I'm gonna take. Case one, I'm gonna take. This is the scenario. Will you be able to let me draw it again in front of you? I shouldn't have drawn it. Okay. See what will happen. How we do? First of all, you need to find the conjugation. You can see pi, sigma, pi, and then vacant orbital. So I'm gonna do this. I'm gonna move towards this and see what will happen. There will be double bond. First of all, there will be double bond. Now this carbon donated its electron, so there will be positive charge. Now the rest part will be as it is. Now you are going to move to this side. And you can see there will be positive charge here, and the bond moves to here, and this was as it is, and this was as it is. Now you need to move this. Now as you can see, double bond moves to here, and this was here, and this was here. There will be positive charge. Again, this will move to this side. These are all resonating structures, which are hypothetical, I told you, which are hypothetical, I told you. And then there will be like this. Now, if you want to draw the resonance hybrid, you just need to draw this benzene first. You just need to draw this benzene first. And wherever the double bond moves, you need to show it with dotted line. Initially, it was here, so I'm gonna draw it here. And then it moves, then there was double bond, and then there was double bond. Now you can see the first, it moves to here, so I'm gonna show it here. Then it moves to here, then it moves to here, and then it moves to here. And wherever the charges comes, whatever is the charge, positive or negative. Initially it was here, so I'm gonna show it delta plus. Then it moves to here, then I'm gonna show you delta plus. Then it moves to here, para position, this is delta plus, and then again delta plus. So this is your resonance hybrid. This is your resonance hybrid. And the above one, that is resonating. So this is how we do resonance. Can you move to the next? Mamuna Allen. Are you able to understand it or not? Mamuna, Alan, Saf, Aksa, Hiba.
Yes, sir.
Okay, Farhad.
Yes, I understand.
Now moving to the next case, that is pi sigma negative or pi sigma lone pair. So how it will take place? It's very easy. You can see it will go like this, and it will move like this. So what will happen here? You can see CH3 will be as it is, This will be as it is. There will be negative charge. Now, since this carbon donated electron, so there will be positive charge. There will be positive charge. So what will happen here? Since there will be positive charge, and this oxygen is gonna donate its electron, so there will be negative charge. So negative positive changed. Sorry, cancelled each other. So this is the resonating structure. Now, if you want to do this, you can do the same. You can see CH3. Now you can see, and then there will be OH positive. I told you in a resonating structure, charges and electrons are balanced. You can count the charge, you can count the electron, and you will see the same electron will be there. And if you are going to count the charge, you can see there is negative, and if you are going to see there is negative. If you are going to see there is zero charge, and if you are going to check there is zero charge, because plus one minus one, I told you to calculate overall charge, and you will be getting zero charge. Is that clear? Can I change the slide? Alan, Aksa.
Yes, sir.
Okay, thank you, Mamuna. Now moving to the next, that is sigma. That is, oh, wait a minute. So will you be able to do by your own the resonating structure, yes or no? Here it is. Oh, still shared. Okay. Are you able to see the screen? Now, pi sigma pi. Now you can see this will move since it is in conjugation, pi sigma pi sigma pi sigma pi. So this will be the resonating structure. And if you want to draw the what we say resonance hybrid, wherever the double bond moves, just denote it. That's why we write it in this way. Or also we write it in this way. Okay. Now see, this is the pi sigma pi. So what will happen? This is more electronegative element, so it will attract electron. So this will be the resonating structure. You can see. Since carbon donated, so it will have delta positive, and this will have delta negative. Okay, again this will move to this, and then you will be getting this part CH2 positive on the first carbon, and the rest part you can see CH and double bond comes between these two, and this is. And if you want to draw the resonating structure, resonance hybrid, you need to show the sigma bond only like this and this. And now what you need to do, initially the double bond was the first position, then comes to the next position, and initially it was between this, and delta negative was there, and then delta positive was at the end there, and then delta positive was there. So you need to do this. Is that clear? Is that clear, everyone?
Yes, sir.
Now, one more important point. The way we divided inductive effect in two parts, plus I, that is donating electron, and minus I, that is accepting electron or withdrawing electron. This resonance can be also divided into two parts, plus R and minus R. And we also call it plus M or minus M. You can see, since this oxygen is withdrawing electron or taking electron from the chain, that's why this will be acting as minus M, and the whole chain is acting as plus M. Now, how you are gonna recognize whether which one is minus M and plus M? So there is a simple trick. If any group that is coming with a single bond and that group has a lone pair, then this group will be acting as plus M. If any group that has a lone pair and that is connected with a single bond, that will be acting as plus M. That means that will donate electron. That means that will donate electron. And if any group that is having double bond and lone pair, then it will withdraw electron. That means it will act as minus M. Are you getting my point? Yes or no? You just need to remember this. A group which has a lone pair, a group which has a lone pair. If this group is connected with double bond, it will be acting as minus M. That means it will it will withdraw electron from the ring or the group to which it is attached. And if a group has a lone pair that is connected with single bond, it will donate. Definitely donate. Are you getting my point? Yes or no? Mamuna, Farhat, Aksa, Anifa, Hiba, Alan. Okay.
Yes, sir.
Okay. I'm gonna show you. You just passed your class 12. So you have seen that this is your phenol. I'm gonna show you. And you have also studied benzaldehyde or benzoic acid as well. So you can see this is your C double bond OH. So what I want to say is that this has a lone pair, this has a lone pair as well. So since this is doubly bonded, so it will attract electron from benzene ring. It will decrease the electron density from benzene ring. And since this is singly bonded, it will donate or increase the electron density. Is that clear? This is a simple trick. That's why I'm telling you. Is that clear? No one is responding at all. Alan?
Yes, it's clear.
Yes, sir. Yes, sir.
Okay, moving to the next case, that is case 4, in which pi sigma and this free radical. Whenever free radical will be there, pi sigma free radical, you need to do homolytic cleavage. You need to do homolytic cleavage. What is homolytic cleavage? Both will take its own electron in this way, and there will be, you can see, there will be an electron, and there was an electron, and there was an electron that will make bond with each other, and it will be the like first CH and then double bond CH2. It will be like this. And if you want to draw the resonating resonance hybrid, you can easily draw it. You can easily draw it like this. Wherever the double bond moves, like this, and delta dot, and then delta dot, and then delta dot. Is that clear? Is that clear, everyone?
Yes, sir.
Now see the next case, which is quite important, and there is d orbital resonance. Whenever carbon anion, that means the rich electron species, is connected with a chlorine, which is having 3d orbital free or 3d orbital vacant. So there will be a resonance, and this resonance is known as d orbital resonance. Fluorine cannot do fluorine cannot do d orbital resonance because it has not any vacant d orbital. So this is a special kind of resonance that is known as d orbital resonance. Is that clear, everyone? Can I change the slide?
Yes, sir.
Okay. Now, rules for stability. Rules for stability of resonating structure. How you are going to, if you have given two or more than two resonating structure, how you are going to decide whether which one is more stable and which one is less stable? So there is simple rule. There is simple rule. The first rule says that the resonating structure which has more pi bond, the resonating structure which has more pi bond, that is more stable. RS stands for resonating structure. resonating structure. You don't think anything. If you are watching that they are resonating structure to each other, the one which has more pi bond, then it is more stable. Now, if it fails, then check the octet. Then check the octet of carbon. Complete octet of carbon or resonating structure will be more stable than incomplete octet. Okay. Then if this fails also, then come to the neutral resonating structure will be more stable than charged resonating structure. The resonating structure which is neutral will be more stable than charged. Now the next, which is very important. If you have two, if you have two resonating structure in which negative charge is on carbon and another negative charge is on oxygen. So always remember that this negative charge on more electronegative element is more stable than less electronegative element. What I want to tell you is that negative charge on more electronegative resonating structure is more stable. Now moving to the next, that is, if opposite charges, that means positive and negative charges are nearer, that is good. And if same charges are nearer, that is not good, because there will be repulsion. After checking these five, you have to check the, if these five are failed, then go for inductive effect. Is that clear, everyone? Please do let me know. Is that clear? No answer, no reply.
Yes, sir. Clear.
Okay, thank you. Just to wait a minute. Can you see a new screen? Yes or no? Mamuna Farhat, is it PDF? Right?
Yes, sir.
Okay, please do the question I just did. Mamuna, very good. This plus M and minus M are very important. That's why you need to take care of that. I told you. Sir, are you done with this? Done with that question? Mamuna, you are done with this. Aksa, Aksa, are you done with that? Everyone is aware of electrophile and nucleophile, right? Yes or no?
Yes, sir.
Yes, sir.
Just wait a minute. I'm gonna give you another question. So everyone filled the form of this NEET, yes or no?
No.
Yes, sir. Very good. Just B, who says it's B? B, MS 53, AB 53. 53 one is, you can see, this is your 1 degree. This is also your 1 degree. No, this is 3 degree, right? Is this 3 degree?
Yes, sir.
And then this is 1 degree. And this is your 2 degree, right?
Yes,
This
sir.
is your 2 degree. And then if you are going to talk about this, then this is also 3 degree, right? But B will be R the most stable. Then comes your, after B, you need to count this 3, 3, 6, 2, 8, 8, 8. And if you're going to check, okay. After B, it will be A, B, and then A. In which case it is coming this and this. Then come to the next, that is 3 to the 6. Okay. Then comes your C, and then comes your E. E is where? E and D. No, E will not come.
BD, right?
Okay, D. D is where? Here it is. Okay, so the answer is B. Everyone is aware. If anyone is facing any problem, please do let me know. Okay. So everyone is done with this. So just let me share a screen that is regarding the resonance. Just wait a minute. Okay. So we were here. Here we are. So we are done with the rules for the stability. Now you need to do the stability order for this 1, 2, 3, 4, 5. I'm waiting. What is the answer for the first one? What you need to do? They are resonating a structure of each other. There is a lone pair. There will be lone pair that is understood. So it will be giving like this, and then there will be double bond and positive on oxygen. So you can see pi bond is more here. That's why it is more stable. That's why it is more stable. I did this in this way. You can see first you need to give preference to the pi bond and then come to the octet and then neutral and then negative charge on more electronegative, then come to the opposite charges on nearer, then inductive effect. This is the order of the stability we need to calculate. So you can see in the first one pi bond is 1 here and there is 0 pi bond. That's why B is more stable. If you are going for this, you can see pi bond is equal. So you need to see carbon has negative charge and oxygen has negative charge. Oxygen is more electronegative than carbon. That's why negative on oxygen is more stable. Now see, this is neutral, this is charged, so it will be more stable. They are equal. If you are looking at this, they will be equal. Now you can see this is your 1 degree, pi bond same, pi bond same, 1 degree, and this is your 2 degree. So this will be more stable. Is it tough to calculate or to arrange? Please answer me for her, Taksa, Mamuna. There was no answer for this question. Can I change the slide? Yes or no? Okay. Now see, mesomeric effect. That is basically same as resonance. The effect due to resonance, that is known as mesomeric effect. So mesomeric effect is of two types. Instead of saying plus r minus r, we say plus m minus m. Plus m is same as plus r. So basically, electron donating group via resonance, that is plus m, and electron withdrawing group via resonance, that is minus m. As I told you, plus m and minus m and plus r or minus r, the bond, the group which is having lone pair and singly bonded, they will donate, and hence they will be acting as plus m. They will be acting as plus m. Always remember this. They will be acting as plus m. And the group which is having lone pair, but they are doubly bonded, so they will attract or withdraw electron. That's why they will be known as minus m. Is that clear, everyone? Please do let me know, yes or no.
Yes, sir.
Okay. Now see, you need to tell me the encircled group, which one is plus m and which one is minus m. I'm going to give numbering to this. A, B, C, D, E, F, G. Can anyone tell me? And from tomorrow's class, I will be taking your class from 5 to 7 p.m. Okay. No one is responding. Farhat, Aksa, Mamuna, Hanifa, Hiba, Alan, Saif. Any answer for the A? In the encircled group acting as plus M or minus M? For any answer, Mamuna, Aksha? You are not audible. Oh, Mamuna. Hanifa, Hiba, Alan, OCS3 plus M or minus M?
So plus
Plus M, it will be acting as plus M because I told you singly bonded lone pair plus M, doubly bonded lone pair minus M. So plus M, and tell me about its inductive effect, minus I or plus I. What do you think? Oxygen will be minus I because oxygen is more electronegative. So we are going to cover the both plus M or minus M or plus I. You can see this will be also plus M and minus I. Here you can see chlorine singly bonded lone pair plus M, and here chlorine is more electronegative element minus I. Here chlorine is there, but no resonance. There will be no resonance here because no conjugation, only sigma sigma sigma. You can see singly bonded O negative charge plus M and minus I will be there. What do you think? O negative will be acting as minus I or plus I? It will be acting as plus I because it has more electron density. So it will be acting as plus I. Now only it will be plus I. There is no resonance here. If you are going to talk about this will be minus M and then minus I. If you are going to talk about this will be minus M and minus I. It's very easy, isn't it?
Yes, sir.
Okay, so this is it for today. In the next class, very less topic left here. So I'm gonna cover this as well as the aromatic hydrocarbon tomorrow, and there will be class from tomorrow 5 p.m. to 7 p.m. So please be ready. And since it's a crash course, I will recommend you to okay. Everyone has PYQ's book, previous years of NEET. Do you have? If you
Yes,
don't
sir.
have, just let me know so that I will be sending you because I have that in soft hard copy, not soft copy. I'll be sending that. Okay. Aksa, Farhad, Alan, is there any
Yes, sir.
doubt in today's class? Just ask me if you haven't got anything or if you have any doubt.
No, sir.
Okay, so this is it for today. I'll see